Hello, AP Statistics. This is Mr. Kim here. We will be talking about the Chapter 4 free response questions that I gave you for practice here. So the first question that you see is the question from 2016. Alzheimer's disease results in a loss of cognitive ability beyond what is expected with typical aging. A local newspaper published an article with the following headline: Study finds strong association between smoking and Alzheimer's. The article reported that a study tracked the medical histories of 21,123 men and women for 23 years. The article stated that for those who smoked at least 2 packs of cigarettes a day, the risk of developing Alzheimer's disease was 2.5 times the risk for those who did not smoke. So here the question they're asking you is the explanatory and the response variable. The explanatory is the type of treatment that was given to the subjects here. So if it was indeed, for example, an experiment. In this particular case, I think it's best if we answer question B first. Is this an observational study or an experiment? The biggest difference between observational study and experiment is that are you, as the person who's doing this survey or the study, are you imposing any sort of treatment to the subjects? In this case, you are observing, study tracked the medical history. So you're not imposing groups of 2 and imposing one group to smoke cigarettes and then imposing the other group not to smoke cigarettes and making comparisons. Remember, we talked about those 4 essential elements that makes up the experimental designs, and clearly we don't have one of those in here. So this is not going to be an experiment. I'm going to answer part B first and say this is an observational study. And always you must provide the reason as to why. There is no evidence of imposed treatment. Here, I think the study simply tracked the medical histories of the subjects and observed that people who smoked at least 2 packs of cigarettes a day had 2.57 times higher risk of developing Alzheimer's. Okay, there we go. So basically what you want to say for part B is that there is no evidence of imposed treatment. You are not imposing any treatments. You simply made an observations here of these 21,000 men and women and saw that smoking at least 2 packs of cigarettes a day can cause 2.5 times higher risk of Alzheimer's. But you're just making that observations, and you're not. It's not an experiment because of that reason. I think I think nothing more needs to be said regarding that right there. So part A, explanatory variable. So explanatory variable is whether or not the subjects have smoked the cigarettes or not, because that's the type of treatment or the observation that you're trying to make. So explanatory is the cigarettes smoked in a day, and the response variable, as the word suggests, is the response to the treatment that's imposed or response to the explanatory. Explanatory is always the providing the explanation as to why the response happened. The response would be developing higher risk of Alzheimer's. Okay. All right. So in here, we will see that I think we have all the answers. The cigarettes smoked in a given day. I think what they also want you to have is the degree of smoking. So how much did you smoke on a daily basis? Was it 1 pack, 2 packs, less than 1 pack, and so on. So degree of smoking, but explanatory is the cigarette smoked, and then the response is the risk of developing an Alzheimer's. Part C, exercise status. Regular weekly exercise versus no regular weekly exercise was mentioned in the article as a possible confounding variable. So what is a confounding variable, first of all? It provides alternate explanation that is part of explanatory variable, that explains the response variable. Simply put, it's any other things or characteristics, causes that could explain why the response variable happened. So C talks about exercise as one of the possible confounding variable. And now here, no math is involved. You're simply going to think about as to why someone with an exercise habit versus someone who does not have a regular weekly exercise habit, how could that influence one person's ability to develop Alzheimer's or not? Well, the answer is quite simple. If you are one of those people who has a very good healthy diet and a very good routine exercise in your schedule, then the possibilities and the chances of you developing an Alzheimer's should be a lot lower. Correct? I mean, that should be kind of common sense. So what you want to say here is that explain how exercise status could be a confounding variable. Well, people with regular weekly exercise schedule could potentially have healthier lifestyle, healthier diet, and not prone to smoking high degree of cigarettes. I know my word could be a lot better than this, but basically what I'm trying to say is that the more exercise that you do, the less likely you are to smoke a cigarette, right? Because that smoking cigarettes and exercise are kind of the opposite ends of the pole here. So if you are one of those people that has a weekly exercise schedule, but could end up smoking, let's say a degree of a little bit, their chance of developing an Alzheimer's might be a lot lower than compared to a person who has absolutely no regular exercise schedule and smokes the same amount of cigarettes. So let me go back here. So people with regular weekly exercise schedule could potentially have healthier lifestyle, healthier diet, and not prone to smoking high degree of cigarettes. Therefore, even if they were to smoke cigarettes, their chances of developing Alzheimer's could be a lot less than that of the no regular weekly exercise subjects. So in comparison to which makes exercise habit a confounding variable because it can impact the chances of developing Alzheimer's. Okay, so first, what you need to have here is that you need to first say, how does the exercise influence the Alzheimer's? How does the potential confounding variable explain the response variable? That's number one. Number two, I think what they wanted also here was that the part C, they wanted to state that the exercise might influence or the person develops a disease. So pretty much, why does the having a healthy lifestyle or doing the exercises here could potentially lessen the chances of developing Alzheimer's? you want to state that in terms of the degree of how much you understand. I mean, exercise habits, healthier lifestyle, that is the reason as to why you will have a lower chances of developing this disease. Anything of those sort, I think it should be good. And so this should be giving you a full credit of 4 points if you have stated all those things in these elements here. You don't have to state it exactly word for word as what I've said, but the essence of all of these things should be there. Okay, so without further ado, let's go to the next one. The next one here, we are talking about the deer in the highways. We're emitting a sound devices that will frighten deer before they reach the highway. And 20 devices along a 2-mile stretch of a road. When a deer approached the device would activate and emit a sound. The researchers recorded whether the deer moved toward the highway, away from the highway, or did not move. So we also have different types of treatments here. Okay, so the loudness is kept at 60 decibels, but the pitch of the sounds were different. We have 0, 0.28, 1, 8, 15, and 28, so there are a total of 6 treatments. The order of treatments was randomly assigned. Now, you might be wondering as to what's the difference between loudness and the pitch of the sound. The pitch of the sound has everything to do with the frequency of the sound. It tells, like, if you're thinking of, let's say, in like an orchestra, like, or singers, sopranos versus bass has a very low frequency and sopranos have a very high frequency. So it's basically how fast a wavelength happens in a given sort of like a span of time, let's say. So this will have a lower pitch than compared to this. Now, the loudness have everything to do with the amplitude of the sound. The amplitude is how high the wavelength goes from top to the middle of it, like the axis of symmetry, if you will. So the loudness is basically determined by the amplitude of the sound. So this 60 decibels and these pitches measured in hertz, kilohertz, I'm sorry, they're all different things. We are keeping the sound, the loudness of the sound at a constant 60 decibels, but we're keeping the pitch to be different. If you wanted to have the explanation, there's a great YouTube video as to explain what the hertz and the loudness of a sound is versus a frequency of a sound is. Okay, I will provide you with a link on the description of the video. Part A, the control in the experiment was 0. So this is the basically control. What information is gained by using the control with no sound that could not be obtained if no controls were used? The only purpose as to why 0 kilohertz were used is to find out that the different pitches of the sound we all have in those 5 treatments, but does the pitch of the sound matter is the question. So we always want to compare it to the bass, which is absolutely emitting no pitch at all. So it gives you some sort of a foundation as to compare it to. If 0 kilohertz gave you something that absolutely was completely just irrelevant to, even if you had different pitches, then there probably is no use of changing the pitches. Maybe the explanatory variables should be different and your response variable is not really adding up. So here, the reason why we want to use 0 kilohertz is that we have a base number to compare it to. We have 5 different pitches in using the device. However, 0 kilohertz control gives us something to compare it to that enables us to see if the degree in the pitch matter. Or in other words, pitch could be the explanatory variable to deer's response of moving out of the highway for the highway or staying neutral. Okay, so somewhere along those lines, as long as you provide the reason as to having the different pitches provides us different magnitudes, but also the zero gives us something to compare it to see if the pitches actually matter in this scenario. What is one advantage to keeping the loudness a constant at 60 decibels for all treatments? It allows us to see if the pitch is the explanatory variable. And by keeping the loudness the same, we eliminate it as a potential confounding variable. So what this means is that if, let's say that we gave different treatments of the pitches to different loudness, that means that depending on the, so you might not know if it's the loudness that's creating the ears to behave in certain ways or the pitches that's causing the ears to behave in certain ways. So if we keep the decibels at a constant 60 and provide different pitches for the ears to listen to, that means we can solely concentrate on the pitch itself to see if that's the reason as to how the deer is reacting to this device. So it allows us to see if the pitch is the explanatory variable, and by keeping the loudness the same, we eliminated it being the loudness as a potential confounding variable. So it provides us to only focus on the pitch and nothing else. What is one disadvantage? Well, it's pretty much a double-edged sword if you think about it. By keeping the loudness at 60, and we are not really then considering if loudness could potentially be a explanatory variable, right? So the disadvantage is that we are limiting the potential confounding variable and limiting the loudness to only 60 when it could potentially explain the response variable. In this case, how the deer reacts to the device. Okay, so the disadvantage is that if you keep the decibels to be the same, 60, and we're not giving different treatments of different decibels for different deers, that means that we are only assuming that, you know what, the loudness is not really going to matter. We're only limited to 60. But what if you were to increase the loudness? There could be potential confounding variables there. There could be potential different responses to that we are limiting ourselves to seeing. That is what you want to say. That's the essence of what part B, Roman numeral 2, is going to be about. Last but not least is part C. These right here, this is called segmented bar graph. So in a segmented bar graph, you will see that we're going to go over this in chapter 1, and I know that I'm giving you something that you probably haven't seen before, but it's quite easy to read. It's 100% of the data, and by having a zero pitch, a kilohertz, then you have the legends that you can look at, and this is 100% of all the data that's for just this 0 kilohertz. That we have 100% of the data for the 0.28 kilohertz and so on, and how much of that relative percentages of the negative, neutral, and positive is clearly shown in a visual manner. Now, when you take a look at this, one thing that you should probably notice is that there is absolutely not much of a significant difference between the negative. I mean, yes, 0.28 is more, 28 kilohertz is more, but not significantly. The same thing is pretty much the same for the neutral and the positive. They are give or take about the same. It's not like, as the pitch increases, the positives goes from like this to like this to like this, and the bar keeps on increasing, and you're able to clearly see that. If you don't see an obvious clear relationship here, it's safe to assume that, you know what, there probably is no importance of increasing the pitch whatsoever here, and that's the conclusion you want to make. Based on the results, would you recommend using a sound emitting device to keep deer from running across highways? I would first clarify by saying no. Does not seem to be a clear indication that the sound emission from the device prohibits deer's movement towards the highway. And obviously you want to create one more supplemental sentence. What do you clearly see in the graph? That as you increase, I want to avoid the word you as much as possible during the free response. So as the pitch increases, you can see that there does not seem to be much change from one pitch to another. Therefore, it is it is unclear, or it is without evidence, or it is unclear, it is without evidence that the sound emission by pitch necessarily influences deer's response. I'm kind of being lazy here, but the response, obviously you want to replace it with deer's movements towards the highway, staying neutral, or moving away from the highways. So as long as you say it along those lines, I think it should be fine. I'll also provide you the official College Board answer key as to how they wanted you to answer this question. But if in all honesty, if I was taking this test, as long as you have the essence of it, they really just care about that. I know my wording is not the best in the world. However, I believe I addressed everything I needed to say for this one. So I hope this helps with the chapter 4. Like I said, it's my worst chapter. There's no math involved whatsoever. You're supposed to develop how you're going to design the surveys and things like that, and what type of flaws, biases, confounding variables you see. That's the big one. And please make sure you understand what explanatory and response variables are, what's the difference between observational study and experiments are. I think those two are the biggest thing when you're understanding chapter 4 here. Okay, anyways, thank you so much, guys, and I'll see you guys tomorrow.